Now we're going to try another variation on the joke from the other lesson. So what does a vegan mathematician eat? Roots, whole numbers, natural logs, tree diagrams, and stem and leaf plots. Which makes sense because this is our stem plots and time series plots lesson. So here's some actual grades from a test in one of my AP statistics classes maybe a year or two ago. And I could do a dot plot, but the problem is my lowest grade on here, sadly, is a 55 and the highest is 100. So if I were to do a little dot plot, it would be, a very broad range. So we wouldn't want to use a dot plot because the span is too large and the data is too far spread out. Honestly, I could do a histogram, and a histogram would work. But there's another alternative to a histogram. That's called a stem plot or stem and leaf plot. And it's great for sets of data that have a broad range of values, and it has the advantage that you can actually see each individual data point in there. So if I had a kid who had a 97, he's like, how many people scored above me? He can actually look at the stem and leaf plot and see without saying what his grade is. So first step in making a stem plot is decide what your stems will be. Usually it's the tens place and higher, but it could be the hundreds place or even higher depending on what kind of numbers you're dealing with. Ideally, you should have at least 5 stems, just like we have in histograms, so we can kind of see the shape. So what are the stems for my set of data? Well, they're 5, 6, 7, 8, 9, and 10, and I actually have them drawn right here. So 5, 6, 7, 8, 9, 10 are my stems. Then I'm going to start making branches from each one of these stems. And the leaves that go with the stem will be the digits to the right of the stem. So the number 80 would have a stem of 8 and a leaf of 0. Then I like to make your life easier, it's usually better to create a preliminary stem plot and then do a final. So in your preliminary stem plot, 80, I would put a 0 with the 8. With 97, I would put the 7 here next to the 9. 83, the 3 goes here. Then we put a 6, and 7 on 7, a 0 on 100, and 8 on 60. And we just keep going on until we've gone through all the data points. And so there's my preliminary stem plot. Now, usually what we like to do is you can actually determine medians and other things from these if these are in ascending order. So let's go ahead and rearrange the leaves so they're in ascending order, and here they are. Then the last part is to add a key showing what a stem and leaf represent. In this case, 80 represents a score of 80. Now let's say I only had 80s, 90s, and 100s on this. I could actually split the stems. So I could have 80003 on a branch, then 866, then 9001, and then 967, and then all my hundreds. So that's called basically a split stem and leaf plot. We would put the lower numbers with the upper stem, and the higher numbers go with the lower stem. Now you can also do a back-to-back stem plot. So this is another class I had that took the same test. And the only difference is instead of having my numbers over here, like trying to line up here and going this way, I'm going to be lined up so the leaves ascend going away from the stem. So see how I have 603, 6888 here? For the 60s, I would have them go in ascending order to the left, which is a little weird. So that means the lowest values are near the center and the largest values are further left. So in this case, there we go, 62, 63, 68, 68, 68. So you can compare, and the nice part is then you can say, my first class seems to be doing better than my second class. I have more students that failed, and I have a lot more A's in my first class. And then the kid who has a 97 can say, oh, I was higher than everybody except for 4 people. All right, time series is another graph that's good to look at. They're helpful at looking at behavior of a measured variable over time. So the horizontal scale is used for time, and the vertical is used for the variable being measured. Now, these are actual steps that I recorded in 2017 off of my Fitbit. So it's from January to December in 2017. I'm going to label the category as month and then go Jan to December. All right. And then I have the total number of steps. The highest value I have is 908,683. So let's kind of just go to 1,000,000 steps. And that would look like this, because these are in thousands of steps. I don't want to put the 00. It's just too long a number. So this is 1,000 steps, which is 1,000,000. This would be 800,000, 600,000, 400,000, 200,000. Then I would just plot each point as we go along and connect the dots. And you can notice normally I get roughly 250, close to 300,000 steps. But the unusual thing you can see is that, Mrs. Overman walks a lot in June and July. And that year I was hiking across northern Spain, probably hiked about 300 miles or so from Santander to Santiago de Compostela. So yeah, I logged a lot of steps that summer.